Draw a circle of any radius with center O. Place 2 points A and B on the circumference of the circle. This continuous part of the circle AB is called an arc of the circle. An arc divides the whole circle into two parts. One is shorter and another one is longer. The shorter one is called minor arc, that is AB. Connect the endpoints of the arc A and B with the center O by a line segment. This forms an angle AOB. The longer one BA is called major arc. Now place a point C on the remaining part of the arc and connect the point C with the endpoints of arc AB by a line segment. This forms angle ACB. Now we are going to compare the angle formed at the center and circumference. We are not going to use protractor for measuring and comparing the angles formed at the center and circumference. To compare angles without a protractor, use a compass to draw arcs at O and C. Utilize tracing paper to compare angles. Trace angle C twice and cut it out. Place the cut pieces on angle O. Observe that both tracing angles fit exactly at O, indicating angle O is twice the angle of C. Since angle AOB is formed by two tracings of angle ACB, angle AOB is twice angle ACB. This proves that the angle subtended by an arc at the center is double the angle subtended by the same arc at any point on the remaining part of the circle. Hence, we proved the theorem using an activity. For instance, in a given scenario where angle C is provided as 30 degrees, applying the theorem reveals that the angle at O will be 60 degrees, as it is twice the measure of angle C. Similarly, we can demonstrate another theorem based on the same concept. Now we are going to compare angle at the circumference and center of the circle. Consider angle AOB formed by two tracings. If we shift one half of the tracing to angle ACB, it becomes evident that it perfectly aligns at point C. So, it is evident that angle C is half of angle at center O. Hence, if you are given the measure of angle at center O, you can effortlessly determine angle C at the circumference of the circle, as it is known to be half of the central angle formed. To summarize, the angle at the circumference at point C is precisely half of the angle at center O. We have established that the angle formed at C on the circumference is consistently half of the angle formed at O, that is the center of the circle. For instance, in a given scenario where angle O is provided as 84 degrees, according to the theorem, we can confidently assert that the angle at C will be 42 degrees, as it is merely half of angle O. Verify the two theorems I taught using a protractor. Utilize a protractor for a hands-on exercise in confirming the validity of the two theorems I have presented. And let me know your results. Thank you.